Hello. Good afternoon, everybody. My name is Henny Stevens, and I'm not going to talk about power save like it's just telling in the other story, but I'm going to talk about the power save feature. However, this presentation's title is how we can save trees with APs. I hope at the end of this presentation that will make sense. Please, can you ask the questions at the end? So I work at Wageningen University as a technical architect. And Wageningen University is the most sustainable university in the Netherlands at the moment. Now, why is that? It's 100% energy neutral. It has energy storage underground and also has a lot of fields of solar panels. The mission of Wageningen University is to explore the potential of nature to improve quality of life. And what will improve the quality of life indirectly? That's trees. So I just give an introduction so it all makes sense a little bit later. So the board of directors, they came together and they were thinking, okay, we are 100% energy neutral because we compensate for the power we use. But actually, we don't want to use the power at all. Of course, it's better to not use the power than compensate for it, using solar parks and windmills. So what they did, we have 30 buildings, a little bit more, and they summon all the location managers that are responsible for these buildings, and they ask them, can you come up with a plan at the end of the year that the building you are responsible for will consume less power than it did the year before? Because of course, global warming, climate change, we want to do something at it. We are a green university, so just come up with a plan. So that was their mission. So what happened, the 12 location managers sit together in a room, and one of the guys came up with the idea to turn off the APs. So, do we want to do that? So it looks like this. Location managers came to IT and they say, we want to turn off the APs. When we're not in the building, we don't need wireless, so let's just turn it off. And the wireless engineers say, but they're not meant to be turned off because there's no power on button on these access points for a reason. Because our monitoring system will get an alarm when we turn them off, and maybe the day after, we need to come to the location for the APs that never came back online anymore when we turn them off. So we have not really agree with the idea, but of course, yeah, we also want to help them with the request. So the IT engineers sit together and we think, okay, what if we can just turn off some elements inside of these APs? There are a lot of elements in the APs. You have physical elements and you have the logical elements. So we are thinking, okay, let's turn them off. So at this moment, for the test I did, was on a 79.2 release. We use a Cisco environment, so this is a Cisco feature, but all vendors do it differently. At the moment, I could only disable the USB, but there's no use because there was nothing attached to it. I could disable the 2.4 and the 5 GHz radio, micro and macro. You can see in this picture. First, I'm going to use this one. So you can see here this micro antennas, and the blue ones are the micro antennas. We can turn them off. But you can also see there are other elements inside of this AP, like the dedicated clean air spectrum scanner that scans for interference. So it doesn't need to throw the client off when it does. And there's a radio, IoT radio in this, the green one. I believe maybe in the future we can also control that one. But at the moment of this test, I could only control the radios. I saw in an upcoming release we can also control the spatial streams inside the AP. So we can not just turn off the radio, but we turn down the spatial streams. So in that way we can just turn it down to 1 by 1, still provide Wi-Fi when somebody come online, and then maybe when somebody is on the AP, we turn off, we scale up till 4 by 4. So I think there's a lot of potential in this in the future. But for now, we only tested to turn off the radios automatically. So we came back to the location manager and we say, what if we turn off the elements? You can save power, you can have your green check mark at the board of directors. And location manager said, we don't care, just let us know how much we save and do your IT thing. So we first, I did a real life test, so I didn't did a lab test because I want to see how it is in a real building. So we checked one AP, there were no clients connected. This is a 9130 IP, this is an omnidirectional, just Office AP. It's an AX IP from Cisco. And we measured it with no clients connected, and it consumes a power of 10.7 watt. So we tested that another day because we want to make sure it's every day the same. So a few days later we tested the same AP again, and again it was with no clients connected, 10.7 watt. So then we turned the power save mechanism on this AP, and we measured an actual power consumption of 9.1 watt. We tested this also another day, and also 9.1 watt. So what can we save when we activate this mechanism? We can save up to 1.6 watt per AP. It doesn't sound much, but if you put the percentage at it, you save 15% per AP, and that's maybe something management will like. So, but can we assume that power save idle time is the same at all APs? Well, it's different per AP model, but does it also be different on the same model? Let's find out. So we pick another AP in the same building at another room, but the same model, and we measured 9.4 watts with no clients connected. So that's 0.3 watt more than the other IP. You can see here the difference. So we tested this also another day, same AP in the other room, same model, 9.4 watt. And we checked, yeah, the radios were really turned off, but it consumes more power. So then we tested another AP, just way down the hall, different result. In power save mode, it consumed 9.2 watt. So that's a difference from 0.2 watt, the first one. So the 1.6 watt difference is average. It's not for all APs the same. Here in the red box you see a list of all APs that are actually in power save mode, but you see all different results. Now, why is that? Exactly. Yeah, so we did a cable trace for the first AP and the second AP, and we see a difference in cable length from plus minus 10 meter difference. So how longer the cable and the voltage travel to the cable, it will build up resistance. So the AP at the end needs to consume more power. And that's why it's different, because the cable run is long. So bottom line, if you want to go green, make sure the cable runs.
Dat will be essentially more switches. Yeah.
So what about the trees? Trees can absorb carbon dioxide, also known as CO2. When we enable power save mode for one building, there's an average building of 85 APs, we can save up to 136 watt. It will save us 280 watt a year. Now, when we visualize this, when we put one building at sleep for 11 hours, then we can save 7 trees. We not really save the trees because we're not really cutting them, but we don't bother the trees to absorb the carbon dioxide that comes from these APs because they are off. So what happened when we enable this on scale? We can save more than 35k a day, so we can save up to 5,000 euro a year. Depends what company you are. If you are a government building, you probably pay less than 40 cents per kilowatt, but it's just a point to save money. And for the board of directors, of course, they want to go green. So when we enable this on scale for 2,000 AP, so that would be for a whole campus, we don't bother 240 trees a year. That's a lot. So when we power save the APs, we eventually save life. And that's the story I want to give you today. Thank you.